Now, let's talk about interfaces. An interface is another type in Java. A class is a type, an interface is also a type. So an interface, you can treat an interface as something like an abstract class. We see an example very soon. Alright, so like an abstract class, it may contain any number of abstract methods. It may contain no methods at all. Now here is one difference between an interface and an abstract class. An interface cannot contain any concrete method. It won't compile if you have an interface and you try to write interface and you put in a concrete method. So all methods in an interface need to be abstract. And not only are they abstract, they are all public. No choice. Only public and abstract methods. In fact, you do not even have to put in the two keywords, the public and abstract keywords. When you write a method, when you declare a method in an interface, they will always be public and abstract. You'll see that very soon. Another point about interfaces, and this is again different from an abstract class, all attributes, if you declare attributes in an interface, they will always be public, static, and final, which means that all attributes in an interface will all be public constants. So an interface may be a good place to declare static constants, which you want everyone to use. Now let's take a look at an example of how to write an interface. So like what I've said just now, an interface is something like an abstract class. So instead of public abstract class communicator, I'm going to change communicator into an interface. One new keyword, interface. Alright. Now this makes communicator an interface. And I've said just now that an interface may contain public abstract methods. So I've removed the abstract keyword here. In fact, I can remove the public keyword here. It does not matter. Alright, so these two are abstract methods. Save. And let me compile communicator. So I've created an interface called communicator. The result of the successful compilation will still be called communicator.class. So if you really want to, you can put in the two keywords public abstract. Okay, it will still compile, but these two keywords are actually implied. So I've written an interface called communicator. Now let's move on. Like an abstract class, you cannot instantiate an interface. In other words, you cannot do something like new communicator, where communicator is an interface. You will get a compilation error. You cannot create an instance of an interface. But you can declare a variable of that type. So this is definitely legal. Communicator C. You can declare a variable, an object reference variable of the type communicator. Okay, and C can store the address of any communicator object. And what do I mean by that? Now, as far as a UML class diagram is concerned, this is how you mark an interface. Alright, you put the word interface. There's no need to italicize the interface name. Alright, now in this diagram, I'm showing an interface called communicator. I'm showing two classes, the cell phone class and the smartphone class. Now notice these arrows. Alright, when you extend a class, you use this arrow. When you implement an interface, you use this arrow. Okay, cell phone implements communicator. Smartphone implements communicator. Implements is another Java keyword. Okay, so you can say that the communicator is a super type of cell phone. You can also say that the communicator is a super type of smartphone. Alright, I'll show an example of using the implements keyword very soon. Another difference between an abstract class and an interface. Okay, this is an advantage of interface. A class, in this case C2, a class can implement any number of interfaces or none at all. Alright. So in this example, in this UML diagram, you see that the class C2 extends the class C1 and implements I1, which is an interface, as well as I2, which is another interface. You can implement any number of interfaces you want, but you can only extend one parent class, regardless of whether C1 is an abstract class or a concrete class. It does not matter. Only one parent class, but any number of parent interfaces or super interfaces. So what is the implication when you implement an interface? It is very much like extending a class. When you implement an interface, all the abstract methods in the interface will be inherited to the child. So in this case, all the abstract methods in I2, I1 will go to C2. All the abstract methods in I2 will go to C2 as well. And of course, all the abstract and non-abstract methods in C1, if there are any abstract methods, C1 has to be a abstract class. So all the methods in C1 will go to C2 as well. Now, if there are abstract methods inherited to C2, C2 must override all the abstract methods with a body. Otherwise, C2 has to be an abstract class. Okay, the same rules apply. Now, I mentioned here the is-a relationship still applies. So according to this diagram, it is still correct to say that C2 is an I1, C2 is an I2, and of course C2 is a C1. That's definitely true. So this interface thing is one way, is a feature in Java which kind of like goes around the disadvantages of not supporting multiple class inheritance. Okay, you can implement multiple interfaces, although you can only extend one parent class. Now, before we move on to the next example, let's take a look at how to use a coded example of implementing an interface. So this is the communicator interface. Let me change the cell phone, excuse me, the cell phone class. So instead of extending communicator, we use the new keyword called implements communicator. We implement an interface, and both abstract methods from communicator will appear in cell phone. Over here, I'm overriding, okay, the send message method and the display info method, which is normal. Save everything, and let's try to compile cell phone. It works. So what happens if you want cell phone to implement more than one interface? You do this. The other interface, cell phone may implement communicator and some other interface. Can't think of another name now. Alright, so you can have public class cell phone extends something, implements interface, comma, interface 2, comma, interface 3, comma, interface 4, and so on. If cell phone needs to extend a class, you make sure that the extends keyword is here, parent class. Okay, implements communicator. So of course, in this case, I did not specifically extend anything. Cell phone will automatically extend java.lang.object and implement the two interface. In this case, the communicator interface. Okay. Now let me give you an example, non-coded example. This idea comes from the duck tours. Singapore has this duck tours operator. They bought some World War II amphibious vehicles, okay, a kind of boat with wheels, okay, made it look like a duck. Put a tail here, put a head here, something like that, and people can go on it for a tour along the Singapore River. Now, in this case, there are two interfaces, boat and vehicle. And the boat interface has got an abstract method sail. The vehicle interface has got an abstract method called drive. And Ducky, okay, our amphibious vehicle, implements both the boat and the vehicle interfaces. So Ducky will need to override the sail method inherited from boat as well as the drive method inherited from vehicle and give them a body. Okay, otherwise Ducky needs to be an abstract class. Okay, remember the point I was mentioning earlier that you can declare a type, a variable of the type. So in this case, it is possible to do this. Vehicle v or vehicle v equals to new Ducky. Boat b equals to new Ducky. The variables b and v can be used to store the address of a Ducky object. However, the problem with using the variable of the type vehicle in this case is that you can only call the the drive method. So this is fine, v.drive. Alright, but this is not okay. This is a kind of revision, okay, of some of the topics we have discussed earlier. The reason you can't call the sail method even though the object v is referring to actually has a sail method is because v is of type vehicle and there is no sail method in the vehicle interface. Alright, same for boat. b.sail works, but b.drive does not. Same reason. So of course in this case, a variable of type a variable of type Ducky will be able to sail and drive. This is fine. Okay. Now let me extend the communicator example. I will show you another class called gaming device. So this is a normal concrete class. We have written the communicator interface just now. I'm going to write a new class called smartphone. So unlike the cell phone, you can use a smartphone for playing games. So a smartphone will extend gaming device and implements the communicator interface. Let's take a look at gaming device first. So gaming device is just a normal concrete class, attributes, a constructor which takes in the default height and width, and a method called getScreenArea which returns the product of the height and width. So it's important for gaming devices to have a large screen for gaming, for example. So smartphone extends gaming device, inherits everything from gaming device, including the getScreenArea method, and it implements communicator. Inherits the two abstract methods from communicator, the send message method and the display info method, and overrides them here. I've included a constructor for smartphone, alright, which takes in the width and the height, and which calls using the super keyword the constructor in the immediate parent class, which is gaming device. Interfaces do not have constructors, by the way. Okay, which is a gaming device, and pass in the width and the height. Oops, there's some mismatch here. It should be the height and the width. Let me change this. H and W. H and W. Okay, save it. Let's try to compile smartphone. Alright, and it works. So I've written a test class to create an instance of smartphone. S equals to new smartphone. Pass in the dimensions, let's say 300 by 200 phone. And I can call the send message method, which takes in the message, some message, followed by a number 1, 2, 3, 4, 5, 6, 7, some telephone number. I can also call the get screen size is it size or dimensions method, inherited from gaming device. It's called get screen area. Get screen area, and I'm going to print out the returned value, which should be 300 times 200. Save this and compile test. Let me run test. Okay, so realize that S, which is a smartphone object, has got a send message method, which I actually overrode in a smartphone class, as well as a get screen area method, which isn't in smartphone, but which was inherited from gaming device. Okay, so a smartphone is both a gaming device as well as a communicator. So let's do a quick summary. Interfaces versus abstract classes. I've said at the beginning that interfaces can be viewed as something like an abstract class, but there are some significant differences. One main difference, you cannot have concrete methods in an interface, only public abstract methods. Okay, for an abstract class, you can have either number of concrete methods and any number of abstract methods. So if you really need to have concrete methods in a parent, okay, to be inherited to a child, you have no choice. You have to use an abstract class. On the other hand, if you only need to have a series of abstract methods, public abstract methods, you probably want to prefer to use an interface because it is more flexible. Why is it more flexible? A child class can implement any number of interfaces. And in addition to implementing your interface, the child class can extend another parent class. Okay, for the case of an abstract class, a child class can only extend you if you are the parent and cannot extend any other class, be it abstract or concrete. So in a way, interfaces are more flexible because you allow a child class which implements you are the interface, to have another parent class. So you choose an abstract class only if you have no choice. That means, for example, if you need to have concrete methods to be inherited to the child. Okay, I'll show you some examples of interfaces in the Java library. So this is a version 7 library. Now the class names here, if you notice, some of them are actually italicized. For example, accessible is italicized. If you click on it, accessible is actually not a class, but an interface. Alright? And there is one method called getAccessibleContext. You can click on it and it will definitely be public and abstract. You see, it is not even stated here that it's public and abstract. It will be public and abstract. So the italicized names here, for example, cert path parameters, whatever that is for, are all interfaces. Now abstract classes are here as well, but they are not italicized, okay, in this particular API documentation. For example, abstract action is an abstract class. How do I know that it's an abstract class? Well, it's stated here in the class declaration. Okay. Look at this. This is interesting. Now, the abstract action class is an abstract class. It extends object, all right, basically, and it implements three interfaces: action, clonable, and serializable. All right, which means the action is probably an interface. Yeah, action is interface, and some methods there. So all these are the fields. Now, a field is a is an attribute. Basically, all these fields are public, static, and final. They're all capitalized, meaning they're actually constants, final. And all these methods in the action interface are all public and abstract. So all these abstract methods will appear in our abstract action class. but they don't have to be all overridden. Why? Because abstract action is an abstract class. So it is okay to keep some abstract methods in abstract action. You don't have to override all of them because abstract action is not concrete. This will still compile. Anyway, that's all I have for interfaces.